Okay, what if I told you that the world around you, everything you think is solid and real, isn't? What if the very fabric of reality is just, well, weirder than you could ever imagine? Today, we are diving headfirst into the absolutely fascinating world of quantum physics. I want you to really think about this for a second. What if the tiniest little building blocks of our universe could be in more than one place at the very same time? Yeah, it sounds like something straight out of science fiction, right? But you know what? In the quantum world, that's not the exception, that's the rule. So, to get our heads around this, you've got to grasp one key idea. It's like the universe is playing by two completely different sets of rules. You've got the rules for our big, normal, everyday world, and then you have the strange, mind-bending rules for the tiny quantum world. See, in our world, things are predictable. You throw a basketball, you know where it's going to go. Simple. But in the quantum world, oh man, particles are a totally different story. They don't just follow one path. Nope, they exist as this cloud of possibilities, kind of acting like a solid little object and a wave all at the same time. All right, so let's jump into the first of these bizarre new rules. It's called superposition. And trust me, this is where things start to get really weird. So, superposition. What does it mean? Well, it means a quantum particle, something like an electron, doesn't have one single fixed state. Instead, it exists in all of its possible states at once. Think of it like a spinning coin in the air. It's both heads and tails at the same time, right up until the moment it lands. Or, in this case, until we decide to look at it. I mean, imagine being at home and at work at the exact same instant. Sounds impossible, doesn't it? But for a quantum particle, that's just business as usual. It's hanging out in a superposition of all its potential spots until, bam, the moment we measure it. Only then does it decide to be in a single place. And if you thought superposition was strange, just wait. Get ready for entanglement. This connection is so bizarre, so weird, that even the great Albert Einstein was unsettled by it. He famously called it spooky action at a distance. So here's the deal. You can link two particles together in this really special way. And once they're entangled, they basically act like a single system. Whatever happens to one of them instantly affects the other. And when I say instantly, I mean faster than light. It makes no difference if they're a tiny millimeter apart or on completely opposite sides of the universe. It's kind of like having two magic coins. If you flip one and it lands on heads, you know with absolute certainty that the other coin, even if it's light years away, has just landed on tails. Instantly. It's wild. Okay, this all leads us to our final rule, and this is the one that really ties everything together: the observer effect. This is the incredible idea that in the quantum world, you can't just be a passive bystander. The very act of looking at something changes the outcome. See, down at this tiny, tiny level, to see or measure a particle, you have to interact with it, right? Usually that means bouncing another particle like a photon of light off of it. But that little nudge, that interaction, fundamentally changes what you were trying to observe in the first place. It forces that particle out of its fuzzy cloud of possibilities and makes it pick a single, definite state. Just let that sink in for a minute. This isn't just some philosophical thought experiment. It's a proven reality of physics. The universe, at its most fundamental level, literally seems to behave differently when we're watching it. It's almost like reality is waiting for us to look before it makes up its mind. Now, I know what you might be thinking. This is all super interesting, but what does any of this have to do with my actual life? Well, it turns out these strange, spooky rules aren't just abstract theories. They are the very foundation of our entire modern world. Those transistors inside your smartphone and your computer, they only work because we understand quantum mechanics. The lasers that scan your groceries or play your Blu-rays, that's pure quantum physics. Even advanced medical stuff like MRI machines that can see inside your body are all built on these very principles. This isn't some distant science. It's right here in the palm of your hand. And honestly, we're just getting started. Things like quantum computing are on the verge of changing technology all over again. We're talking about computers so powerful, they could solve problems we can't even properly imagine today. So yeah, quantum physics isn't just about our past. It is actively building our future. So what's the big takeaway from all this? Well, quantum physics shows us a universe that isn't fixed and certain. It's dynamic, it's interconnected, and it's just filled with these mind-bending possibilities. It really shows us that the more we learn, the more magical and mysterious our reality truly becomes. It makes you wonder, doesn't it? What other secrets is the universe just waiting for us to discover?